Hello everybody and welcome to the Cumulative Review Packet number 8 flipped videos that go along with every problem in your review packet. Again, I hope you're using this to your advantage. My suggestion would be to use this video for the ones you got wrong the first time and then to complete the review packet on your own, maybe in a timed manner to see if you're catching any of your own mistakes. So let's start here at number 1. Determine whether the data in the table displays exponential behavior. Explain why or why not. Well, you might remember from class that what we looked at first was to see if the x's had a consistent pattern, and it looks like we're consistently going up by 1, so that's great. And then we focused most of our attention to the y value. The y value represents how high or low a graph is going, and if the y values are adding or subtracting in pattern, that is not fast enough to be exponential, but if we notice there is a multiplication or division pattern, we talked about in class that goes very quickly, so the multiplication or division pattern is fast enough to be exponential. So because I noticed that to get from 27 to 9, we're dividing by 3, and then the same pattern is dividing by 3. 3 divided by 3 is 1. So because we're consistently dividing by 3, I would say yes, this table is exponential behavior because the division property is fast enough to be exponential. The second part, we are doing more scientific notation, and the reason these are on your review packet is I noticed that for some, you could use more practice on this topic for the next cumulative test. And what we want to do here is use exponent rules. So if we looked at number 2, we have two things in scientific notation, and we want our answer also in scientific notation. And when we have two bases that are the same, and we are multiplying, we add the exponents. So the first thing I'm going to do is times 10 to the 6 plus negative 8 power, which would be times 10 to the negative second. Because 2.5 and 7.4 are not like bases, we cannot do any adding of exponents, but what we can do is treat them like regular numbers, and we could multiply them to become 18.5 times 10 to the negative second power. Now, a lot of you might recognize here that this is not in scientific notation because this number is not between 1 and 10. So what we did in class was we moved the decimal 1 over to the left to become 1.85, but when we move it over to the left, it's moving farther away from where it started, and so that means you have to add a step to your journey. So my answer in scientific notation will be 1.85 times 10 to the negative first power. Number 3, if we're using exponent rules, I again notice that we have like bases of 10, and when we have like bases and we are dividing, we are really subtracting the exponents. So to have 10 to the negative 4 minus 9 power, which would be 10 to the negative 13th. And just like the last problem, the 3.2 and the 8 are not like bases, so we would have to divide them normally, and 3.2 divided by 8 is 0.4. So far I have 0.4 times 10 to the negative 13th power. But, just like number 2, I am not in scientific notation. So I have to move my decimal 1 over towards the right, and so the decimal is more towards where it wants to go, towards the end of the number. So that means I need to subtract a step this time. So as we talked about when in class, when you move the decimal to the left, you add onto the exponent, and when you move the decimal to the right, you subtract from the exponent. So my final answer here would now be 4 times 10 to the negative 14th power. Number 4, if I'm following exponent rules again, I am raising both of these to the third power. So if I stick with the 10 first, if I am raising a power to a power, I am multiplying the exponents. So I'd have times 10 to the 12th power. But also, this is 7.2 to the first. If we multiply 1 times 3, it would be 7.2 to the third power. And 7.2 to the third is really 373.248. Now, like the last two examples, this one is definitely not in scientific notation because this number is not between 1 and 10. So I'd have to move the decimal over twice this time, so my number is now 3.73 0.248 times 10 to the 12th. Now I moved my decimal twice to the left. When I move it to the left, I have to add to the exponent. This time, because I moved twice, we'd have a +2 rather than a +1 up there. So my final answer would be 3.73248 times 10 to the 14th power. Speaking of exponent rules, what I've chosen here for 5 to 8 were the most missed exponent rules on your last cumulative test. So I'm making sure to hit these again in this cumulative review. So if I looked at number 5, we have a bunch of bases divided by more bases. And if two bases are the same and we are dividing, we are subtracting the exponents. If the bases are not the same, we treat them like regular numbers and reduce. So if I focused first on my x's here, I would have x to the -3 minus -5th power. If I looked at my y values here, I would have y to the 6th minus -8. Please be careful with your negatives here. And then if I looked in green to the 8 and the 24, these are not like bases, so I'm going to leave it as 8/24 for now, but I will reduce that soon. If I do x to the -3 minus a -5, that's really a plus. So this is really x to the +2nd. This is also changing to a plus, so that will be y to the +14th power. 8/24, 8 goes into 24 3 times, so this could be reduced to 1/3. We are not subtracting these because we do not have any exponents that we can subtract. So far, my answer is 1/3 x squared y to the 14th. But if I wanted to make that answer more compact, I would have x squared in the numerator, y to the 14th in the numerator, and then I would have a 1 on top technically and a 3 in the denominator. So that would be my answer for number 5. And remember, when you do the subtracting rules, your exponents are automatically back in the numerator. As soon as you apply this subtraction rule and this subtraction rule, everything starts back in the numerator, which will help us later. If I look at number 6, I have 1, 2, 3 bases that are all being raised to the -3rd. This 5 really has an exponent of 1. And when I have a power to a power, I multiply the exponents. So I would have 5 to the 1 times -3 power, a to the -4 times -3rd, and b to the 7 times -3rd. So this would really be 5 to the -3rd power, a to the +12th power, and b to the -21st power. Remember, the goal of these problems is to have no negative exponents. So both this base and this base have to flip to the denominator. And when I do that, I would have a to the 12th on the top, 5 to the 3rd on the bottom, and b to the 21st in the denominator. The last thing I could do is reduce 5 to the 3rd, 5 times 5 times 5, to be 125. So my final answer would be a to the 12th over 125, b to the 21st power. Please remember that when you flip exponents, that they become a positive no matter when you flip them. If you flip them up, they become a positive. If you flip them down, they become a positive. And please remember that negative exponents give you reciprocals, not negative numbers. Number 7. Please notice that both parentheses have a power on the outside. So just like this example, we would raise a power to a power first. And so in the first parenthesis, I have 3 bases. I have, again, this is really raised to the first. So I have -3 to the 3rd power, x to the 4 times 3rd power, or 12, y to the 6 times 3, or 18, for the first part. The second part, -4 and the base of x are raised to the 2nd. So I would have -4 to the 2nd power, and I would have x to the -18th power. If I continue to reduce my numbers first, -3 to the 3rd is -3 times -3 times -3, which is a -27, x to the 12th, y to the 18th. And then a -4 squared is -4 times a -4, which is a +16, x to the -18th power. Now, one of the biggest mistakes I saw on the last cumulative test was not paying attention to negatives. Please make sure when you're cubing a negative, the answer is still negative. When you're squaring a negative, it's negative times itself, so the answer would be a positive. So what I would do now is look for like bases. When I have the like bases of x and x, I'm going to add my exponents. So I'd have x to the 12 plus negative 18 power. Y doesn't have a base to combine with, so I'm just going to leave it. But the numbers are not like bases, and so I'm not going to add them. I'm going to multiply them because I cannot apply the exponent rules if the bases are not the same. So negative 27 times 16 gives me negative 432 in the front. So I have negative 432, x to the negative 6th power, y to the 18th power. Now another reminder, this answer isn't done because I have this negative exponent. Remember, this does not flip to the denominator because the exponent on this number is a 1. The number is negative, which is okay. The exponent is positive, which means it does not flip. So my final answer will be negative 432 in the numerator, y to the 18th still in the numerator, but then x to the 6th flips down to the denominator. The last exponent rules example, number 8, applies to the 0th exponent. When every single thing in parentheses is raised to the 0th, all of this does become the number 1. However, in the next two examples, this is really 8 to the 1st times x to the 0th. This becomes 1, so we're really left with 8 times 1. And this piece becomes 1, y to the 0th is still 1, so it's minus 12 times 1. So I have 1 plus 8 minus 12, which would be 9 minus 12. So my final answer is just a single number of negative 3. The next piece, these are the growth and decay word problems we've been talking about recently, and this is similar to what your test will look like. I will give you all three formulas, and it is your goal to make sure you know when to use each one. This is the exponential growth formula, this is the exponential decay formula, and this is the compound interest formula. Okay. So if we take a look at number 9 to start, determine the amount of an investment of $4,500 if it's invested at an interest rate of 5.5%, compounded quarterly for 10 years. Now, as soon as I see this word compounded, and I notice that the money's not done over a year's span, my eye goes to this first equation here. A equals P times 1 plus R over N to the NT. And so what we need to do is represent or figure out what all these letters represent in the problem. P, or the principal value, is how much money we start with. And so that would be the $4,500. The R represents my rate of increase or decrease. In this case, that's 5.5%. But as a decimal, that would be, move it over twice to the left, 0.055 is my rate. My time is how much time is passed, which is 10 years. And the new part about this equation is the N value. And the N represents the number of times I'm taking out money per year. So I'm taking out money quarterly. And by taking out, I mean it's compounded, so that's how often the interest is applied. So that really happens quarterly, which means 4 times a year. So that's why the N value is 4. And so if I plug all this information into my equation, it would look like this. A equals 4,500 times 1 plus 0.055 over the number of times the money's taken out or compounded, 4, raised to not just the time this time, we need to take into account how much it's taken out, so it will be 4 times 10 years. So if we want to calculate this, we would do so completely in the calculator. We would start inside out. We would first divide 0.5 divided by 4, then we would add 1, then we would raise that answer to the 40th power because of 4 times 10, and then we would multiply it by 4,500. And since I'm running out of time on this video, I will start with the next video using the calculator here that I have via my calculator or via my computer to show you how to do this in the calculator to remind you. So please stop the video here and please start video 2, and I will start with the calculator portion on number 9. All right, thanks guys.